Good morning, everyone. In the last session of data warehousing and data mining course, we saw about the differences between OLTP systems and OLAP system, online transaction processing systems and online analytical processing systems. So the main point over there was online transaction processing systems are used for day-to-day transactions, and online analytical processing systems is used by decision makers for data analysis and decision making. Online transaction processing system consists of always the current updated data, whereas online analytical processing systems will have data stored from a historical perspective, past 5 to 10 years of data. Also, online transaction processing systems will have detailed data since it is used for day-to-day operations, whereas online analytical processing systems will have summarized, integrated, and consolidated data. Okay, so we use short atomic transactions for accessing online transaction processing systems, and we use complex queries for accessing online analytical processing systems. So this was the major difference between OLTP and OLAP systems. Also, in the last class, we saw about multi-tiered architecture of a data warehouse. In the bottom tier, it was the data warehouse server and the metadata dictionary. Data warehouse servers can be in two forms, the enterprise warehouses or data marts. We will be studying in detail about enterprise warehouses and data marts in today's session. We also saw the bottom tier consisted of a metadata repository. So what do you mean by metadata? Metadata is data about data. So what all data are stored in the data warehouse will be mapped in the metadata directory or repository. Metadata repository serves as a directory which helps to locate the contents of the data warehouse. The middle tier is composed of OLAP servers, which can be a ROLAP server or a MOLAP server, relational OLAP or multi-dimensional OLAP. What is an OLAP server? OLAP server is a way of organizing the data for faster analysis and querying. The most or topmost layer is the front-end tools, which is used for reporting and other data mining tasks. So this is a brief overview about what we have seen in the last class. Let's go to today's session. Let's see the agenda of today's session first. In today's session, we will be seeing about the data warehouse models and about data warehouse development. Okay, so let's quickly go to data warehouse models. So there are three data warehouse model. That is, first is enterprise warehouses, the second is data marts, and the third is virtual warehouses. So what is an enterprise warehouse? From the word itself, you can tell it collects all the information about the subject spanning the entire enterprise or entire organization. Okay, a single warehouse maintained for the whole organization, containing the information about the whole organization, about the subject spanning the entire organization. For example, if you have a college is an organization. Suppose you are having a central data store containing all the information about the teaching staff, all the information about the non-teaching staff, all the information about the admissions, all the information about the students, all the information about the curriculum being followed. Okay, so a central data store containing all the information spanning the subjects of the entire organization. Such a warehouse is called enterprise warehouse. That's why we tell it as enterprise warehouse, because it contains information about the whole organization or entire organization. So it is cross-functional in scope. Okay, as I told, it will include subjects which belong to the whole organization. So it is called as cross-functional in scope. Okay, so we have to do data integration, which will be corporate wide. So it will be having corporate wide data integration from external information providers. Okay, then it will be comparatively huge in size. It can be even terabytes also in size. Okay, so enterprise warehouses, since it contains integrated information about the whole organization, it will be huge in size, maybe in terabytes also. Since it is very huge in size, it cannot be implemented in ordinary machines. It will be implemented in super servers or traditional mainframes. So this is about enterprise warehouse. What is an enterprise warehouse? Enterprise warehouse will be having the information about the whole organization, information spanning the entire organization in a single central data store. Okay, so that is cross-functional in scope and huge in size. When I tell huge in size, it can be measured in terms of terabytes also. Okay, and basically the information stored in the enterprise warehouse will be highly summarized, because we have to store the cross-functional information. We have to store information about the entire organization. We will try to keep it as much as summarized as possible. Okay, and usually it will be implemented in traditional mainframes or computer super servers. So this is about the first data warehouse model, enterprise warehouse. Coming to the second one, the second data warehouse model is a data mart. What is a data mart? Data mart is nothing but a subset of the enterprise warehouse. Data mart is a subset of the enterprise warehouse, a subset of corporate-wide data that is of value to a specific group of users. Its scope is confined to specific selected groups. For example, if suppose the HRD department wants to keep track of its employees, you can create a data mart of employees alone, okay, belonging to a particular institution. Earlier I told, if you have a college, if suppose you are having a central data store containing all the information about the employees, about the students, about the curriculum, about the admissions. So everything, if it is stored in a single data store, it become a enterprise warehouse. But a subset of the enterprise warehouse, which contain information of specific subjects, okay, which is of importance or which is of value to a specific group of users. Such a warehouse is called as data mart. Okay, so its usage or its scope is confined to specific selected group of users. One example is given in this slide. If suppose you are having a marketing data mart, okay, so marketing data mart may deal only with subjects such as customer, items or sales. If you have a big organization, in the organization there can be multiple operational databases. Now from those operational databases, if I take data relevant only to sales or relevant only to marketing, then I can construct a data mart specific to marketing. Okay, and the main subjects over there will be customer, product, sales, profit, etc. Okay, I hope it is clear. It's nothing but a subset of the enterprise warehouse. Enterprise warehouse spans the entire organization, whereas the data mart is a subset which contain only information related to a specific subject, information which is relevant only to a specific group of users. Okay, so since it is subset, the data size will be lower compared to enterprise warehouses, and it is usually implemented on low cost departmental servers. Okay, so data mart comes in two varieties. The first one is independent data mart. The second one is dependent data mart. So what is independent data mart? So in case of an independent data mart, you will derive the data directly from the operational databases. So independent data marts are built from operational databases. What about dependent data mart? Dependent data marts will be derived from the enterprise data warehouse. It's not from operational databases. I hope you know the difference between operational databases and data warehouse, right? Operational databases are heterogeneous. Operational database will be multiple in number belonging to a particular organization, and it consists of data which is used for day-to-day operation. That's why it's called as operational databases used for day-to-day transactions or operations. Whereas data warehouse is basically used for senior management for decision making, right? So independent data mart will be built or derived from the operational databases. Okay, whereas dependent data mart is derived from the main or the enterprise data warehouse. Okay, that's why we tell it as dependent. It's dependent on the enterprise data warehouse. It's dependent on the content of the enterprise data warehouse, right? So you have two varieties of data mart: independent data mart and dependent data mart. Independent data mart is derived directly from the operational databases, whereas dependent data mart is dependent on the enterprise data warehouse, or it is derived from the enterprise data warehouse. So if you have to construct a dependent data mart, you have to first construct the enterprise data warehouse. How do you construct an enterprise data warehouse? You have to construct it by deriving data from the operational databases. You have to derive the data from the operational databases. You have to perform data transformation, which we already studied about. Okay, you have to perform data pre-processing and transformation, construct the data warehouse and keep it. From the data warehouse, you can derive subsets of it. Okay, and that represents dependent data marts. Whereas what is independent data mart? From the operational databases, first you are not going to build the enterprise warehouse. Instead, from the operational databases, you will take the relevant data, okay, about the subject which you are interested in. That relevant data will be derived and you will build independent data marts. From these independent data marts, we can build the enterprise warehouse as well. Okay, so this is about the second warehouse model, that is the data mart. Now the third data warehouse model is the virtual warehouse. From the word itself, you can understand virtual. Virtual means what? Not real. Okay, so virtual warehouse is just a view over the operational databases. So you are not actually constructing that warehouse, you are just providing a view on the operational databases. You would have studied about views in DBMS. Okay, so virtual warehouse is not a physically separate data store. Instead, it's just a view. It's not real. That warehouse will not be implemented in real. Instead, it is virtual. It's a view over the operational databases. You will show the relevant data which you are interested in. Okay, you will be projecting only the relevant data which you are interested in as a view. That is called as a virtual warehouse. Okay, so only some of the possible summary views may be materialized. So all the views you cannot show, only some of the possible views can be materialized. So these are the three data warehouse models: enterprise data warehouse, data mart, and virtual warehouse. What is enterprise data warehouse? Enterprise data warehouse is a single data store spanning subjects of the entire organization or entire institution. Okay, so it will be very huge in size and implemented in traditional mainframes or computer super servers. Okay, when it comes to data mart, it's a subset of the enterprise warehouse. Data marts are a subset of the enterprise warehouse. Data mart consists of information relevant to only a particular subject. Okay, data mart will be used only by a specific group of users who are interested in that particular subject. It's a subset of the enterprise warehouse. So data mart is comparatively smaller in size and it can be implemented in low cost departmental servers. Now, two varieties of data marts are dependent data marts and independent data marts. What are dependent data marts? Dependent data marts are dependent on the enterprise warehouse. First, you will build the enterprise warehouse. From the enterprise warehouse, you will derive the dependent data marts. What is independent data marts? Independent data marts are derived from the operational databases. So you will first derive the independent data marts. From the independent data marts, you will build the enterprise warehouse. Okay. The third data warehouse model is the virtual warehouse. From the word itself, you can understand virtual means not real. Okay. So here we don't have an actual physical warehouse. Instead, it's just a view over the operational databases. You will just show as a view the relevant data. Okay, so only few views may be materialized or can be materialized. Okay, so that is about virtual warehouse. These are the three data warehouse models. Okay, now we'll go to the next topic, that is data warehouse development. Okay, there are basically three approaches for data warehouse development. First approach is the top-down approach. Second approach is the bottom-up approach, and the third approach is a hybrid approach. Okay, so before starting itself, I will tell you hybrid approach is better preferred or recommended, but we have to learn about top-down approach as well as bottom-up approach in order to understand hybrid approach. Okay, so data warehouse development, the first one is top-down approach. So what is top-down approach? In top-down approach, you will build the enterprise warehouse first. Okay, you all know what is enterprise warehouse by now. So first we will be building the enterprise warehouse. From the enterprise warehouse, you will be deriving the dependent data marts. In case of top-down approach, from the word itself you can understand top-down. Okay, so first you will build the top enterprise warehouse, the warehouse or the central data store containing information about the whole organization. Okay, so that enterprise warehouse will be first built, and from the enterprise warehouse you will be deriving the subsets or the dependent data marts. Okay, now what is the advantage of this top-down approach? The main advantage of this top-down approach is that it minimizes integration problems. So here what we are doing, from the operational databases, you all have the detailed data in the operational databases, correct? So from the operational databases, you will be building the enterprise warehouse, correct? So you are building the high-level structure first, right? From the operational databases, you are building a warehouse, a central store containing all the information in a summarized version, right? From the enterprise warehouse, you are building the data marts. So this minimizes integration problem. Why? Why? Because you are building the combined version first. From there, you are dividing, you are deriving the subset. So that's why it minimizes integration problem. Instead, if you were combining data marts and building the enterprise warehouse, there can be conflicts while integrating it, while combining it. Instead, here what we are doing, from the operational databases, we are doing a time-consuming operation over multiple stages. You will do data transformation, you will do data pre-processing, you will do data cleaning, refining of data. You will take all those relevant data, make it as a summary and save it in the central data store. From that central data store, whichever is the relevant information needed for each particular subject, you will derive the data mart. So that's why we tell that it minimizes integration problems. Now, what about the disadvantage? This approach is highly expensive, time consuming, and it lacks flexibility. Why it is expensive and time consuming? Because see, building the big enterprise warehouse is not so easy, right? So we have to take care of concurrency issues. We have to take care about naming convention. You have to take care about attribute conversions, right? So many things has to be done. So much of steps of refinement has to be done on the data belonging to the operational databases. So it takes a lot of time to build the enterprise warehouse, right? So this is a expensive and time consuming approach, and it also lacks flexibility. Now the next approach is bottom up approach. From the word itself you can understand bottom up. So first you will be building the data marts, right? Small subsets you will be building. You will be building the data marts from the operational databases. So I have mentioned build independent data marts. So separate data marts belonging to a particular subject will be built first. Then you will integrate these data marts and build the enterprise warehouse. Okay. So this is a opposite of top-down approach, right? Now, what's the advantage of this approach? It is flexible and low cost. Why it is low cost? It is low cost. Why? Because it's easy to build small data warehouses or data marts, right? It's easier to build, or it takes less time to build data marts, right? From small data marts, that time onwards we will start doing data pre-processing, right? Now once you have a subsets, once you have many subsets, it's easy to combine and form the main database, right? So this is a flexible as well as low cost approach. But what's the problem here? There can be integration issues. So when you combine the data marts and build the enterprise warehouse, there can be concurrency issues. There can be problems with naming conventions, etc. So integration problems are more in case of bottom-up approach. Okay. So we have seen two approaches, top-down and bottom-up. Okay. So both has its own advantages as well as its own disadvantages. Now understanding this or analyzing this, we are trying to derive a hybrid approach. Okay, so that is better recommended. So in case of this hybrid approach, what we do here is you will define a high level corporate data model. You will define a high level corporate data model. So here, what is high level corporate data model? This high level corporate data model will have data spanning the entire organization. It will be similar to enterprise data warehouse, but it is not so much time consuming to build a high level corporate data model. Why? Because we will not put data in so much minute level. You will just put a high level data, you will just build a high level model. Okay, it will not be having all information and all. It's just a high level model just to compare it, right? So it is slightly similar to enterprise data warehouse. It's not as much as refined as the enterprise warehouse. The high level corporate data model will not be very much refined as enterprise data warehouse, but you will be building a corporate wide data model. Now from the corporate wide data model, you will do model refinements and parallelly build the enterprise data warehouse as well as the data mart. So you are building parallelly the enterprise data warehouse as well as the data mart. So this high level data model will be further refined. As I told, it's just high level. It doesn't contain the minute details. Though it spans the entire organization, it is just the high level model. So from the high level model, you will be doing refinement and building the enterprise data warehouse. Parallel to that, you will also be building the data marts. Okay. Now, once you build the data marts, you can combine few data marts and build the distributed data marts. Okay. And from the distribute, so now if you compare this figure with the 3-tier architecture of a data warehouse, you can relate that. In the bottom tier, you have the data warehouse as well as the data mart, right? Now, in the middle tier, you have the OLAP servers. So, these OLAP servers is a way of organizing the data for fast query, right? So, these contents of the data mart, contents of the distributed data mart and the enterprise warehouse will be organized in a particular way, and it forms the multi-tier data warehouse. And all the data in the multi-tier data warehouse, the custodian will be the enterprise data warehouse. Enterprise data warehouse is spanning the entire organization. So the custodian of the multi-tier data warehouse will be the enterprise data warehouse. Okay. So here what happens is, we told that in top-down approach, the main advantage is that it minimizes integration issues. Okay, so we are taking advantage of that scenario here by building a high level corporate data model. Okay, so we are building a corporate high level corporate model, so that from that high level corporate data model, we are not directly deriving data marts or enterprise warehouse from operational databases. We are defining a high level model. From that high level model, we are deriving the data mart and enterprise warehouses. So there won't be any integration issues. Integration issues are minimized here. At the same time, the advantage of bottom-up approach was fast. It's less time consuming, right? Here also, since we have built the high-level corporate data model, from that we are building the data mart and enterprise data warehouse. It is less time consuming. For building high-level corporate data model, it doesn't take much time. From that high-level corporate data model, we are building data mart and enterprise warehouse parallelly. So that means it will not be time consuming. So we are trying to extract the advantages of both top-down approach and bottom-up approach and use this recommended approach. I hope it is clear. I repeat how we are deriving the advantages. The advantage for top-down approach was that it minimizes integration issues, because you are building the enterprise warehouse. From the enterprise warehouse, you are deriving the data marts, right? So there it minimizes integration issues. But the disadvantage over there was the time consumption. It takes larger time to build the enterprise warehouse, because enterprise warehouse must be highly refined. Okay, so we will follow a mediocre path. In the mediocre path, what do? You are building a corporate-wide data model at high level, not as refined as the enterprise warehouse. Okay, at a high level, we are building the corporate data model. From that corporate data model, you are deriving the data marts and enterprise data warehouse. So it minimizes integration issues. At the same time, it will be less time consuming. Okay, so from the high level corporate data model, you will build the data marts and enterprise data warehouse. The data marts can be combined together to form the distributed data marts, and finally you can build the multi-tier data warehouse architecture. And the custodian of all the data of multi-tier data warehouse will be the enterprise data warehouse. So this is all about data warehouse development. So in today's session, we have seen 3 data warehouse models. Which are the 3 models? Enterprise warehouses, data marts, and virtual warehouse. We also saw about data warehouse development, top-down approach, bottom-up approach, and the hybrid approach. Thank you.